Hello student, in this lecture I will discuss how we determine or how we will determine a point on the root locus. Okay, so the topic name is determination of points on the root locus. So let's start our lecture or discussion. Okay, so see here we consider a system with open loop transfer function in pole 0 form is GSHS equal to k into s plus z1 into s plus z2 up to s plus zm divided by s plus p1 into s plus p2 up to s plus pn. Okay, here I have given this equation is equation number 3.21. Here n greater than m, z1 z2 zm are open loop zeros and p1 p2 up to pn are open loop poles. Okay, now we have already seen in previous lecture there are two even conditions. So one even condition is modulus of ps equal to modulus of gshs equal to 1. This is called magnitude criteria. And second condition is angle of ps, that means angle of gshs equal to plus minus 2q plus 1 into 180 degree, where q equal to 0, 1, 2, 3 like this. This is called angle criteria. Okay. Now from this equation, that means equation number 3.21, we can write modulus of GSHS equal to k into modulus of s plus z1 into modulus of s plus z2 into modulus of s plus z3 up to s plus modulus of s plus zm, and this divided by modulus of s plus p1, modulus of s plus p2, modulus of s plus p3 up to modulus of s plus pn. Okay, and here I have given this equation is 3.22. Okay, so see we can write this equation by this way. Okay, and here the number of this equation is 3.23. Okay, now for angle we can write angle of GSHS equal to angle of s plus z1 plus angle of s plus z2 plus angle of s plus z3 up to angle of s plus zm minus angle of s plus p1 minus angle of s plus p2 minus angle of s plus p3 up to angle of s plus pn equal to plus minus 2q plus 1 into 180 degree. Okay, I have given this equation is 3.24. Okay, so see we can write this equation by this way. Okay, so here I have written summation of angle of s plus zi, where I varies from 1 to m, minus summation of angle of s plus pi, where I varies from 1 to n, and this is equal to plus minus 2q plus 1 into 180 degree. Here I have given the equation number is 3.25. Okay, now see we have already known that the values of s in the s plane that satisfy equation 3.25 are part of the root locus. Okay, for every point s that satisfy equation 3.25, there exists a k satisfying equation 3.24 which can be found from equation 3.23. From equation 3.23 we find the value of k. Okay, so from equation 3.23 we can write k equal to this. Okay, this is reciprocal of modulus of gs, this is reciprocal of modulus of gs hs. Okay, okay, so we can find k by this equation, or we will find out the k by this equation. Okay, so see the value of k at any point s0 on the locus is obtained from this equation. Okay, any point S0, that means any point in the S-plane is S0. Okay, so the value of k at any point S0 on the locus is obtained by this equation. That means equation 3.26 by substituting S equal to S0. Okay, so let me take an example. So to illustrate this, let us consider the transfer function this. Okay, here transfer function is open loop transfer function GSHS equal to k into S plus 4 divided by S into S plus 2 into S plus 1. Okay, so in this equation there are 3 pole and 1 0. Poles are 0, minus 2, minus 1. Okay, these are poles, that means poles. I have mentioned P by poles, and 0 is 1, so 0 is minus 4. Now we put this pole and 0 on the S plane. Okay, so this is our S plane, this is our S plane. Okay, so this point is our origin. Here I have mentioned 0. This is our right hand side and this is our left hand side. Okay, now we place pole and 0 on this S plane. So our first pole is 0. So here I have mentioned this is P3, first pole. Second pole is minus 1. So here I have also mentioned this by P2. Okay, and third pole is minus 2. Here I have mentioned this pole is P1. Okay, and there is 1 0. So 0 is mentioned by Z1. This is our 0. Okay, pole represented by cross and 0 represented by 0. Okay, and this is one point on the S plane, that is S0. Okay, now see so this is the pole 0 plot of the transfer function of this. Okay, now we take an arbitrary point S0 on the S plane. Here I have taken this point S0 in the S plane. Okay, if S0 is a point on the root locus, then it has to satisfy the angle criteria. Which is our angle criteria? This is our angle criteria, because in our transfer function there is 1 0 and 3 poles. Okay, so here I have mentioned the 1 0 and 3 poles. That means angle of H0 plus Z1 minus H0 plus P1 minus H0 plus P2 minus H0 plus P3, and this is equal to plus minus 2Q plus 1 into 180 degree, where Q equal to 0, 1, 2, 3 like this. Okay, now see, the angles are measured with positive real axis. Okay, so angle are measured with positive real axis. If S0 satisfy equation 3.25, that means angle criteria, then the magnitude K at that point is K equal to mod of H0 plus P1 mod of H0 plus P2 mod of H0 plus P3 divided by H0 plus Z1. Okay, so mod of H0 plus P1 is what? The length of this, that means A. Okay, here I have mentioned A, this is A. Okay, and mod of H0 plus P2 is B, and mod of H0 plus P3 is C, and this divided by mod of H0 plus Z1, that is D. Okay, so in this way we find K if our angle criteria is satisfied, then that means H0 satisfy angle criteria, then the magnitude K at that point is this. Okay, so far we have discussed about the basic criteria required for the existence. So in this way we have discussed about the basic criteria required for the existence of a point on the root locus. That means basic criteria is angle criteria, magnitude criteria. First we see angle criteria is satisfied or not. After satisfying angle criteria, then we find the magnitude of K, and then check the magnitude criteria. Okay, so if we find the value of k, then we obviously see the magnitude criteria is satisfied or not. Okay, so here we have discussed about the basic criteria required for the existence of a point on the root locus. However, finding root locus points in the S-plane that satisfy the angle criteria is a very tedious procedure. By using a special tool called spirule, we can find the set of all points on the root locus. But this trial and error method of drawing root locus is obsolete. An approximate root locus plot can be plotted by using the set of hand calculations using construction rules. Okay, so in next lecture, I will discuss the construction rule of root locus. So after the availability of digital computer and software package like MATLAB, you people have already did this MATLAB program of root locus. Okay, so after the availability of digital computer and software package like MATLAB, plotting a root locus is reduced to a simple command to the computer. Okay, however, it is important to know the construction rules to draw the approximate plot, which is very useful in the design of control system. Okay, so in the next lecture I will discuss the construction rules of root locus. Thank you.